Namaste friends. Welcome to the second lecture of interest. In the previous lecture of interest, you have learned the present value and future value. You have learned the simple interest and some problems on simple interest. In this lecture, we are going to learn nominal and effective rate of interest, compound interest, and problems on compound and simple interest. Nominal and effective rate of interest. Nominal rate of interest is also defined as a stated interest rate. This interest works according to the simple interest and does not take into account the compounding periods. It is as good as the rate of simple interest. Effective rate of interest. Effective rate of interest is the one which caters the compounding periods during a payment plan. It is used to compare the annual interest between loans with different compounding periods like week, month, year, etc. In general, stated or nominal interest rate is less than the effective one. Nominal rate of interest is less than the effective rate of interest. Effective rate of interest is generally used to find the compound interest, and nominal rate of interest is used to find simple interest. Amount by compound interest. The formula for the amount by compound interest compounded annually means the rate of interest is given per cent per annum and the compound interest is also compounded annually. Annual compound interest including principal sum means this amount is principal plus the compound interest compounded annually, and it is given by A is equal to P into bracket 1 plus R upon 100 bracket raised to n. See, this formula is applied only when the compound interest is compounded annually, where P is a principal amount which is borrowed by a person. N is the time or period, or you can say it is the number of years. R is the rate of compound interest which is given per cent per annum, and A is the amount accumulated value. This is nothing but the principal plus the compound interest on the principal for the given number of years or the period with the given rate of compound interest R. Similarly, we have the formula for the amount by compound interest compounded semi-annually. Semi-annually means half yearly. Semi-annually means half yearly. Whenever the compound interest is compounded half yearly, it is also called as semi-annually, and in this case the amount of 10 will be given by the formula A is equal to P into bracket 1 plus R upon 200 raised to 2n, where P is the principal amount on which the interest has to be calculated, R is the rate of interest per cent per annum, N is the number of years for which the compound interest has to be calculated. So in these n years we have 2n half years. In these n years we have 2n half years. So here instead of n we are going to use 2n, and R is the rate of interest per cent per annum, but here in this case we are going to compound interest half yearly. We have to use the rate of interest half of the percent per annum rate of interest. So here we have R upon 200 instead of R upon 100. Okay. Now the amount by compound interest, where the compound interest is compounded quarterly. Quarterly means for 3 months, and it is given as a is equal to p into bracket 1 plus r upon 400 raised to 4n, where p is a principal on which the compound interest has to be calculated, n is the number of years, and as in every year we have 3 months, 4 into 3 is equal to 12 months. So as in every year we have 4 quarters, this number of years n has replaced here by 4n, because here compound interest is compounded quarterly. 4n quarters are there in n number of years. Similarly, r is the rate of interest percent per annum, and as we have to calculate here compound interest quarterly, for the quarter that interest will be r by 4. So here instead of r upon 100 we have r upon 400. Similarly, the compound interest when calculated monthly, the amount obtained is given by a is equal to p into bracket 1 plus r upon 1200 bracket is to 12n. Because in every year we have 12 months, this number of years n can be converted into 12n months, where the compound interest is compounded monthly. Similarly, r is the rate of interest percent per annum, means per 12 months. So per month the rate of interest will be r upon 12. So here r upon 100 is replaced by r upon 1200. Thus the compound interest is given by compound interest is equal to amount by compound interest minus principal amount, where p is equal to principal, a is equal to amount by compound interest. Example, a sum of rupees 10,000 is invested at 10% per annum compound interest. Find amount after 3 years. Also calculate compound interest. We have to find the amount by compound interest after 3 years. Here the amount invested, means the principal amount is given to be rupees 10,000. So p is equal to 10,000. We have to find the amount after 3 years. So the number of years n is equal to 3, and the rate of interest is given 10% per annum. So r is equal to 10. As here we have no information whether the compound interest is compounded annually, semi-annually, quarterly or monthly. By default we have to consider that the compound interest is compounded annually. Now the amount by compound interest, when the compound interest is compounded annually, it is given by a is equal to p into bracket 1 plus r upon 100 bracket is to n. Now we have to replace here p by 10,000, r by 10 and n by 3. So we will get a is equal to 10,000 into bracket 1 plus 10 upon 100 bracket is to 3. This 10 upon 100 is nothing but 0.1, and so it is 1 plus 0.1 means 1.1. So we will get a is equal to 10,000 into bracket 1.1 bracket cube, and 1.1 bracket cube is nothing but 1.331. So it will be a is equal to 10,000 into 1.331, and finally we will get the amount by compound interest after 3 years is equal to 13,310. When we less principal from this amount, we will get the purely compound interest after 3 years. So the compound interest is equal to a minus p. It is equal to 13,300 minus 10,000. So it is equal to compound interest as 3,310 rupees after 3 years, while the desired amount is rupees 13,310. Second example, a bank promises to give you rupees 20,000 after 4 years at 8% rate of compound interest. Find today's investment. Here we have not given the investment, means principal amount p. We have given the amount after 4 years, means a is equal to 20,000, n is equal to number of years as 4, and the rate of compound interest r is equal to 8. And as we know, the amount by annual compound interest is given by a is equal to P into bracket 1 plus R upon 100 brackets to n, where A is equal to 20,000 given, n is equal to number of years is given to be 4, R is the rate of compound interest, percent per annum is given to be 8. Now we have to just replace the values to find the value of P. A is equal to 20,000, so it will be 20,000 is equal to P into bracket 1 plus R is 8, so it will be 8 upon 100 brackets to n is 4, so it will be 4. 8 upon 100 is nothing but 0.08, so it will be 1 plus 0.08 means 1.08 brackets to 4. By using the calci, you can find the 1.08 brackets to 4 is equal to 1.36048896. So this 20,000 is equal to P into 1.36048896. This multiplied term to the P can be transferred to the left side and it will divide 20,000 and we will get the value of P as 14,700 rupees 597 paise, or it will be approximately 60 paise. Hence the today's investment or the principal amount is approximately rupees 40,760 paise. And the compound interest on a sum of money at a certain rate for 2 years is rupees 2,200 and rupees 2,310 respectively. Find the rate and the sum. Here we are given the simple interest on certain amount. That certain amount is not given, so P is not given here. On that certain amount for 2 years, means number of years is equal to 2. The simple interest is given as rupees 2,200, so SI is equal to rupees 2,200. The rate of interest is not given because here we have mentioned at a certain rate, means R is not given, and the simple compound interest is given to be rupees 2,310. Therefore, thus see here simple interest is 2,200 rupees for 2 years, and we know that the simple interest is same for each year. For 1 year, simple interest can be calculated by dividing this 2,200 by 2. So we will get the simple interest for 1 year is equal to 1,100. Also, the difference between compound interest and simple interest means difference between 2,310 minus 2,200 will be 110. This 110 rupees difference between compound interest and simple interest is nothing but the interest on simple interest of first year, because for the first year simple interest and compound interest are same, and in the second year compound interest is calculated on the original principal plus simple interest of first year. So this increment is due to the interest on the simple interest of first year, means this 110 rupees is obtained as simple interest on 1,100, which is nothing but the simple interest for the second year on 1,100 for first year. And we know the formula for the simple interest as SI is equal to P into N is into R upon 100. You can replace here simple interest is equal to 110 rupees. P, as this 110 rupees simple interest is on 1,100, so you have to replace P by 1,100, and it is obtained for 1 year, so you can replace N by 1 and you will get is equal to 1,100 into 1 into R divided by 100. So R can be calculated as 110 into 100 divided by 1,100. So it will be R is equal to, there are certain mistakes, 110 into 1 into 100 divided by 1,100. Okay, so this 110 into 100, it is equal to 11,000, and divided by 1100 it will be 10. So R is equal to 10 rupees rate of interest percent per annum. So the simple interest on the required sum of money for 2 years at 10% is 2,200. The meaning of this rupees 2,200 simple interest for 2 years is on a certain sum, means principal P, at a rate of interest 10%. Again, by using the formula for simple interest, SI is equal to P into N into R divided by 100. We will get, we can replace simple interest by 2200. Principal is unknown. Number of years is 2 because this interest is on for 2 years. Rate of interest we have already calculated as 10%, so we have to replace R by 10 divided by 100. Now this value of P can be obtained by P is equal to 2200 into 100 divided by 2 into 10. After calculation, this 2 into 10 will be 20. When we divide 2200 by 20, it will be 110. 110 into 100, it will be 11,000. So the principal amount will be rupees 11,000 and the rate of interest will be 10%. Example 4, find the accumulated value at the end of 2 years of rupees 8,000 invested at 7% per annum compounded half yearly. We have to find the accumulated value means amount at the end of 2 years means n is equal to 2. Here n is equal to 2. Rate of interest is given as 7% per annum and the amount is given as rupees 8,000. As we have to compound the interest as compounded half yearly, you have to use the formula for the amount by compound interest semi-annually, and it is equal to, it is given by A is equal to P into bracket 1 plus R upon 200 raised to 2n. Now replace P by 8,000, n by 2, R by 7, we will get A is equal to 8,000 into 1 plus 7 by 200 bracket raised to 2 into 2, 2 into 2 becomes 4, and this 1 plus 7 upon 100, it will be 207 by 200, it will be 1.035, and we have to find 1.035 raised to 4, and after calculation we will get amount by simple interest, amount by compound interest compounded half yearly as A is equal to 9180.184005. Thus the desired accumulated amount is approximately 9,180 rupees. Fifth example, the difference between simple interest and compound interest on a certain sum for 3 years at 6% per annum is rupees 100. Find the sum. We are given the difference between simple interest and compound interest on a certain sum for 3 years at 6% per annum. As we have the information, we have not given the principal amount because here we have mentioned on a certain sum for 3 years means n is equal to 3. At 6% per annum rate of interest means R is equal to 6, and the difference between simple interest and compound interest is rupees 100 means CI minus SI is equal to 100. As we have the formula for simple interest as P into N into R upon 100, simple interest will be obtained as P is unknown, keep as it is, into N is equal to 3, R is equal to 6 divided by 100. While the compound interest is equal to amount by compound interest minus principal is equal to P into bracket 1 plus R upon 100 bracket raised to N. When we have no information about the compound interest, whether it is compounded half yearly, annually or quarterly, etc., by default you can consider it is compounded annually. So we will use the formula for the amount by compound interest compounded annually as P into 1 plus R upon 100 bracket raised to N minus P. It is equal to P into bracket 1 plus R upon 100 bracket raised to N minus 1 bracket complete. You can replace the values and you will get CI is equal to P into bracket 1 plus R is 6 upon 100 bracket raised to number of years is 3 minus 1. So by replacing the values, we will get the difference between compound interest and simple interest is equal to 100. The compound interest is P into bracket 1 plus 6 upon 100 bracket raised to 3 minus 1 minus simple interest was 18P upon 100. You can using the calculator we can find the value of the square bracket as 0.191016, and this 18 upon 100 is 0.18, so it will be P into 0.191016 minus 0.18P is equal to 100. When we subtract this, we will get 0.011016 times P is equal to 100, and so P is equal to 100 upon this 0.011016, and approximately it will be equal to 9077 rupees 71 paise. So the principal amount on which this difference is given to be 100, it is equal to 9077 rupees 71 paise approximate. Example 6, at what rate per cent per annum a sum of rupees 1600 to rupees 2025 after 2 years compounded annually? Means the principal amount is given to be rupees 1600 and this amount after 2 years compounded annually is given to be 2025. Means A is equal to 2025, number of years n is equal to 2, P is equal to rupees 1600, and the rate is not given. We have to find the rate of interest, and it is compounded annually. The amount by compound interest compounded annually is given by is equal to P into bracket 1 plus R upon 100 bracket is 10. Substitute all the values except the unknown R. We'll get 2025 is equal to 1600 into bracket 1 plus R upon 100 bracket is 2. Divide 2025 by 1600. So we'll get 1 plus R upon 100 bracket square is equal to 2025 divided by 1600. The number 2025 it is the square of 45. Number 1600 is the square of 40. So after taking square root on both sides, we will get 1 plus R upon 100 is equal to 45 upon 40. Now this can be simplified as 5 9s are 45, 5 8s are 40. So it will be 9 by 8. So we will get 1 plus R upon 100 is equal to 9 by 8. Shift this 1 towards right, we will get R upon 100 is equal to 9 upon 8 minus 1. It will be 1 upon 8. Shift this 100 towards right, you will get R is equal to 1 upon 8 into 100. It is equal to 12.5. Thus the required rate of interest is 12.5% per annum. Seventh example, a sum of rupees 1000 to rupees 1728 in 3 years compound interest. Find the rate. Here principal is 1000, A is equal to rupees 1728, amount by compound interest compounded annually by default, number of years is 3, and we have to find the rate of interest R. Similar as the before, we can substitute the values and find the 1 plus R upon 100 bracket cube is equal to 1720 divided by 1000. As 1728 is a cube of 12 and 1000 is a cube of 10, you can replace this by 12 by 10 bracket cube. Taking cube roots on both sides, we will get 1 plus R upon 100 is equal to 12 upon 10. It can be simplified as 5 by 6 by 5, and after subtracting 1 from that 6 by 5, will get it as a 1 by 5 or 2 by 10, and shifting this 100 towards right, you will be R is equal to 1 upon 5 into 100, it is equal to 20%. So R is equal to 20% rate of interest. Eighth example, the difference between simple interest and compound interest on an account of rupees 32,000 for 2 years is rupees 150. Find the rate percent per annum. Here principal amount is given as rupees 32,000, number of years is given to be 2, and the difference between simple interest and compound interest is given as 150. We have to find the R as the rate of interest. P is 32,000, N is equal to 2 years, R is unknown, SI and CI have the difference, CI minus SI is equal to 150, which is nothing but the simple interest on second year. We know that for the first year simple interest and compound interest are same. In the second year, the simple interest for first year and second year are same, but the compound interest is increased due to the simple interest on first year. So this difference is due to the simple interest on first year. So it will be the interest on simple interest of first year, but simple interest is equal to P into N into R upon 100. So we will get this simple interest 1 for the 1 year is equal to 32,000 into 1 into R upon 100 is equal to 320R. Here principal is given to be 32,000. For the first year, simple interest on this 32,000 rupees principal amount, it is equal to 320R. And on these simple interest on the first year, the simple interest is given to be rupees 150, the difference between CI and SI. Now we have to write the formula for the simple interest rupees 150 as a simple interest on 320R for 1 year. We will get 150 is equal to simple interest on first year into 1 year into rate of interest divided by 100, and this simple interest on for first year is obtained as 320R. You can replace it by 320R into 1 into R by 100. After calculation, we will get this R square is equal to 150 into 100 divided by 320, or 1500 divided by 32. It is equal to 46.875, and it is square of 6.85. So the rate of interest R is 6.85% per annum. Thank you. After learning these topics, you will be able to find the compound interest on a given amount for a given period. You are able to understand and find the difference between simple interest and compound interest. If you have any question, you can find me at mrsanjaymas@gmail.com. If you like this video, please subscribe the channel to see the next important and interesting lectures. Thank you.